In these problems, we assume that the data has a normal distribution and the number of observations is greater than 50. So we want to find the critical z-value used to test a null hypothesis. In the first problem, we have a two-tail test. So I'm going to show my distribution. And since this is a two-tail test, we're going to split the value of alpha to the two sides. So I'm going to show roughly about here, and I don't have to be exact. I just want to know that the area in the right-hand tail is 5% divided by 2, so that's 2.5%. And then the area in the left tail is also 2.5%. So we need to find the two critical values because this is a two-tail test. So I can I can eliminate anything that doesn't have a plus or minus, but since all the choices do, we have to go ahead and calculate. All right, so I'm going to put in inverse norm, and I'm going to go ahead and find the critical value for the left-hand tail. Oops. So I'm going to find this value. So inverse norm of 0.025, and then we have 0 and 1. And this gives me a negative 1.96. So I can put that here. And then that means in the other tail, my critical value is positive 1.96 because of the symmetry. We're using the standard normal distribution. So that's plus or minus 1.96. Now let's take a look at number 4, where we're working with a right tail test. So since we're in the right-hand tail, we've got 9% in that right-hand tail, and let's say it's roughly somewhere here. And this area is 9% or 0.09. So I'm going to do inverse norm. I want to put the area to the left. That's how the inverse norm function works. So if there's 9% in the right-hand tail, that means there's 91% in the left-hand tail. And when I put that in, I get positive 1.34. So that's going to be this choice. There's only one critical value in a right tail test, so I know that the plus or minus has to be incorrect. And then finally in question 5, we have alpha equals 0.05 for a left tail test. So I'm going to put an area of 0.05 in the left-hand tail, or 5%, whichever way you want to write that. And so we're just going to calculate inverse norm. We already know the area to the left. And this turns out to be negative 1.645. So that's our choice, and that's how you do those problems.